Hey everybody, this video lesson is going to talk about the periodic table of elements. I like to think of it as a work of art. It's organizing the elements in columns and rows, and it's functional, but also fashionable. Let's first talk about individual elements on the periodic table, and I'm going to zoom in here on boron to give us an idea. First of all, the information that you'll find here is that the number in the upper left-hand corner is what is known as the atomic number, and we already talked about this in a previous video lesson, but now you know. Of course, in the middle there's a symbol that has a capital letter and sometimes a lowercase letter along with it. The symbol sometimes matches the name, which is right underneath it, but doesn't always match the name. Finally, this last number underneath is called the average atomic mass, and it's a number that runs out a couple digits past the decimal. But for the most part, it's close to a whole number. So if you just round this number to the nearest whole number, you get the mass number of this element. And remember, the mass number is the sum of the protons plus the neutrons in the nucleus of this element. So let's zoom back out here so that we can take a good look at the whole periodic table. Now we're going to talk about some key vocabulary terms so that you know a little bit more about the periodic table. First of all, the periodic table is organized into rows that run horizontally and vertical columns. A row on the periodic table is called a period. That's where the periodic table gets its name. Periodic table. It means that the rows are organized into periods. A column is defined as a group, and you will often be referencing groups or periods of the periodic table. For example, the group that starts with oxygen includes sulfur and selenium and tellurium and polonium and livermorium. So these elements all are in the same group. Normally, when we talk about a group of things, it could be any in the general vicinity. But in chemistry, a group is very specific to a column of elements. So let's see if you know the difference between a period and a group. I'll give you an example. If I say, what is the element in period 4, group number 13? Well, there's some things on the side of the periodic table that can help you. First of all, the periods might not be numbered down the left-hand side, but you could add in some numbers. You can call this period 1, period 2, period 3, 4, 5, 6, and 7. There are technically 7 periods on the periodic table. Now the groups, on the other hand, run across the top, and these are numbered. 1, 2, 3, 4, 5, all the way up to 18. The last column of the periodic table is known as group 18. So if I ask you, what element is in period 4, group number 2, well, you kind of work this like a map. If I say, what house is at the intersection of 2nd Street and 3rd Avenue, that's kind of the same situation. So once again, I said period 4, so you go down to the 4th period and across to the 2nd group, and you found yourself calcium. That is the element and the only element that will ever be located at period 4, group number 2. And so let's try another one. What element is located on period 3, group 15? Let's see if you can find it. Well, if you go down the period, starting with period 1, period 2, period 3, and now go all the way across until you get to group 15, which is the column with nitrogen and phosphorus in friends. So period 3, group 15 is phosphorus. Let's try one more. What element is in period 5, group 17? So you go down to the 5th period, and if I know 18 is the end, then it's one inside group 18, must be group 17, that is iodine. So it's very important that you know the difference between a group and a period on the periodic table. The next thing that I want to talk about on the periodic table is how all the different elements are organized, because there's a very specific organization to the periodic table. It is designed to look this way very purposefully. There are basically 3 sections of the periodic table. If you would imagine the periodic table as an entire city, then there are 3 neighborhoods. One of them is very large, one is kind of small, and one is very small. But they are very important that you know where they are. First of all, let's talk about the 3 different parts of the periodic table. We've got what are known as the metals, things known as nonmetals, and then things that are known as metalloids. Now metals, First of all, as you know, if you could think of an example of a metal, they would be things like iron, or even silver or gold, copper. All of the metals that you're familiar with are probably lying in this section of the periodic table. But more than just silver, gold, and copper represent metals. In fact, all of these elements in this lower left-hand side of the periodic table are known as metals. Now, what makes metals unique? Well, they all are solid at room temperature, with the exception of one of them, which is liquid at room temperature, but they're all solid at room temperature. Furthermore, they all generally have a shininess to them. They are shiny, or what we call luster. And another key characteristic is that metals always form positive ions, or what we call cations. If you have your periodic table in front of you right now, I recommend that you pull it out, because I'm going to highlight the elements that are considered metals on the periodic table. Now, most of the periodic table are metals. It's about 85 to 90% of the elements that you know on this table are metals. That includes these bottom two periods on the bottom that kind of look like they're separated from the periodic table, but in fact they're part of the periodic table just like the rest of these elements are. And so here are the metals. I've outlined them in blue. Now let's talk about the nonmetals. Now, the nonmetals are also grouped together in a certain section of the periodic table, and they are located in the upper right-hand corner of the periodic table, representing this little triangle up here. It includes carbon and nitrogen, oxygen, and all the other elements that are kind of around it. Now, what makes nonmetals different than metals is that instead of just being solid, like all metals are solid at room temperature, nonmetals tend to be liquids or gases at room temperature. Some of them are solid, like carbon, but not all of them. And so they come in all different states of matter. But the one thing that makes them very different than metals is that instead of forming positive ions, nonmetals always form negative ions. And so I'm going to outline them in red at this time. All of these elements represent nonmetals. Now, if you're looking at my periodic table at this point, there's a couple of elements that are not considered metals or nonmetals, and they lie on this silly diagonal line between the blue elements and the red elements that you can see, and these are called the metalloids. These elements have properties that aren't quite like metals, and they're not quite like nonmetals. They're kind of a hybrid of both of them. Think of them as part metal, part nonmetal, which is why they kind of formulate the border between the metals and the nonmetals. They are typically solid at room temperature, but they could form positive ions or negative ions, so you can see that they have properties of both metals and nonmetals. I'm going to identify the metalloids with the color green. Now, as you look over the periodic table, you'll see that all the elements have been identified as either a metal, a nonmetal, or a metalloid, with the exception of one element, and it happens to be the very first element on the periodic table. Hydrogen is one of the most interesting elements. It behaves like a metal, but looks like a nonmetal. I'm not saying it's a metalloid, because that's not what it is. It is definitely a nonmetal that behaves like a metal. So that's what makes hydrogen unique. It is a gas at room temperature, but will always form positive ions. In summary, we've discovered a little bit more about the periodic table and how it's organized. We talked about the difference between a group and a period, and we also talked about the three different ways that the periodic table is broken down, whether it be by metals, by nonmetals, or by metalloids. Well, that takes care of this video lesson. Thanks for watching.